So section 3.6 is a summary of curve sketching. What you're going to do is take everything that you've learned in order to sketch a graph without using a calculator. So some things you're going to want to consider. First is x and y intercepts. Second is symmetry. Next is domain and range. These are all pre-calc topics so far. Then we get into some things with calculus, continuity, asymptotes, differentiability, relative extrema, increasing and decreasing functions, concavity, points of inflection, and finally limits at infinity. So these were, these first few are in the preliminary section of the calculus book. Continuity is section 1.4. Vertical asymptotes is 1.5. Horizontal is 3.5, but also remember you did those in pre-calculus. Differentiability is 2.1. Extremis 3.1. Increasing and decreasing is 3.3. Concavity is 3.4, as well as points of inflection. And limits at infinity were 3.5. And this will be tied to horizontal asymptotes as well. So we're going to look at an example and utilize all the things that we just wrote down on that page. So our example is we're given a function 2 times x squared minus 9 over x squared minus 4. So we're going to sketch this function without using a calculator. So first thing that we're going to look at is what's in the domain. Right, so the domain, when you're looking at these, you're looking for denominators and you're looking for square roots, right? Because we can't have anything that makes a denominator 0 and we can't have anything that makes a square root negative. So those are kind of the two basic things you're looking for. So in this example, we have a denominator x squared minus 4. So x cannot be negative 2 or positive 2. So basically all real numbers except for those two. Now let's next look at x-intercepts and y-intercepts. Okay, so remember when it crosses the x-axis, y equals 0. When it crosses the x-axis, crosses the y-axis, x equals 0, crosses the x-axis, y equals 0. I think I said the same thing twice, but you get the point. So if we look at this, when is the whole thing equal to 0, right? So when does y equal 0? And remember, when y equals 0, it simply means that the numerator equals 0, because if the numerator is 0, as long as the denominator is not 0, 0 divided by any number is 0. So we can kind of ignore the 2 because it's just a constant, and we look at x squared minus 9, and we would get 3 and negative 3. So our x-intercepts are 0, negative 3, and 0, 3. Y-intercepts. Right? We find the y-intercept by plugging in 0 for x. So we get 9 over 4. Okay, thought I had paused there and hadn't. So we're going to look at, we're going to set up kind of a table. So we're going to use all the intervals, and then we're also going to use the points. And for each of them, we're going to look at the function, the first derivative, and the second derivative. And then we're going to draw a conclusion based on that. Okay, so in the intervals, we don't look at what the function's doing. Okay. At 2 and negative 2, it was undefined. And it's also undefined in the first derivative and the second derivative. And the reason for that is because it's a vertical asymptote. Oh. go back and look at 0, right? At 0, the value is 9/2. We found that. And 0 was a critical point, right? So that's when the first derivative was 0. If we plug it back in to the second derivative, we'll look at that in a minute. We plug it back into the second derivative, it's positive. The second derivative test tells us take our critical points, plug it into the second derivative. If it's positive, then it's a relative minimum. So this is the one that's the opposite. Okay, so now let's look at our intervals. So remember that we pick a test value in that interval. We can pick -3, -5, it doesn't matter. We find out if it's positive or negative. This one's going to be negative. This one's going to be negative. This one's going to be positive. This one's going to be positive. And the second derivative here is negative. So I would suggest that you look at this page while I graph it, because we're going to utilize this. I guess I don't have all the second derivatives in here to graph it. So the second derivative is negative during that interval, positive during that interval, positive at that interval, negative there. And then conclusion-wise, right, this talks about, first derivative tells us if it's increasing or decreasing, second derivative tells us about concavity. So this is decreasing concave down, right? This is decreasing concave up. This is increasing concave up and increasing concave down. So now I would look at this sheet and I'm going to graph it. Okay, so let's start with a couple things that we know. At 2 and -2, we have vertical asymptotes. We also talked about at 2, we have a horizontal asymptote. Then we have also our x and y intercepts. So at -3, 0 and at 3, 0. And then our y-intercept is at 0, 9/2, or just over 4. Okay, so your x and y-intercepts. So we have our asymptotes, our x and y-intercepts. Now we're going to use that chart to start to graph it. Okay, so from -∞ to -2, it's decreasing and concaving downward. Well, we know that this point is on the graph and it's decreasing, and we know that the graphs follow the asymptotes, so it's decreasing and concaving downward. Then from -2 to 0, it is decreasing, concaving upward. Well, we know again, it's going to not go lower than the asymptote, so it's going to come down and go to 0. Then from 0 to 2, it's increasing concave up. And then from 2 to infinity, it's increasing concaving down. And you can always put a couple other test points in. Like if you weren't sure, you could put in 1 and see what you get. Put it right into the original function and get a couple other points. So any additional points that would help you graph it. So that's basically, in a nutshell, sketching a graph. You're going to use your asymptotes, your x and y intercepts, and then using the first derivative test and the second derivative test, or first derivative, second derivative, and the second derivative test to find your increasing, decreasing in points of concavity. Also, one thing I missed kind of when sketching it, at 0, 9/2 was also a relative min, so that's the other reason you know that the graph's going up here. So if it's decreasing concave up, if that hits a minimum, then the graph can't be below it. All right, so now you can try some on your own.